Thanks, Carlos. Some innovative uses of your UAS data, so we appreciate hearing about that. All right, our next presentation is from the West Virginia Department of Highways. We have 3 presenters coming up for us, and they'll be discussing UAS and digital twin use cases. None of the 3 of them have bios, so maybe they can do a self-introduction, but we have Jesse Bennett, David Callahan, and Travis Long.
Very important. All right, thank you. So a lot of this yesterday, I think I covered, and it's the same group, so I don't like to repeat myself, but we'll talk a little bit about our program and some of the things on it. Mostly, we want to get to a use case situation. Talking about some just basics that we've had. Early on when we were building this program, we come up with, some of these sort of touchdowns where we wanted to be and things that we wanted to do. And one of the things that we said when we came to management and we had this cost savings I talked about yesterday, which was $342,000 per year by just doing our stockpiles, was that we wanted control over picking pilots. So it was cross-classification, and like a lot of us that get into this, it was not nobody has a drone classification in a DOT. There you go. So some of you do now. 5 years ago we didn't, and we're on our way to that now. Daniel is with me today. He is our first full-time pilot. That's all he does is fly and process. We're getting ready to add another. So we went from that. We didn't want people to take chances. We wanted to try to keep the program. I used to give this talk about, like, if you're a bridge inspector and you drop a hammer off a bridge or bust somebody's windshield, our insurance is going to cover it. Probably other than a second level supervisor, nobody will know. But I could take the same DJI P4, drop it off a bridge, bust your windshield. I'm in the news. It might just get spun up. It might go national. Next thing I know, my whole program's grounded. So those were the kind of things we wanted to be careful about. We're kind of pivoting a little bit right now, and now the discussion that we've grown in 5 years is that maybe we should go from having 2 or 3 pilots in every district to going back to maybe we need about a half a dozen full-timers. People who do this all the time, and this is their job, so that just makes sense in every classification that we do. I'm not a bridge engineer, but I have one within reach, and so he can advise me about section loss and things like that. So same concept with that. So if you're in that stage, first of all, you're like really happy that you got people that want to do the job, and it's kind of just extra. And then I think you kind of morph into back, maybe we should just have people who do this all the time. So that's one thing advice I would advise when it comes to personnel and pilots. We are almost solely digital twins now. We do have a LiDAR unit. I really appreciate the honesty, and we had it here earlier today about some of the tethered drones. But I'm a skeptic about drone LiDAR. I've been working with LiDAR for a very long time, and drone LiDAR has a lot of problems. The biggest problem is the cost. And I'd love for someone to prove me wrong, but I think you have to get into that 250. Like, you got to be at the $250,000 stage before you're going to get into the accuracies that you need, especially for like pavement design, things like that. So the thickness of your fuzz, we should talk about this a lot in LiDAR. That's the thickness of your fuzz matters. And so that should be the first thing you look at when you get a LiDAR. And then penetration too, because you got to have a lot of data or a lot of light points on a lot of returns to get that bottom penetration when you're trying to do things through vegetation. So the processes are easier too. So that's, I think, is why a lot of us are going more to digital twins. So we don't have the trajectory calculations that we would normally have to do, running pause pack and rerunning it and having problems with it and then running it again if you've ever been in that world with mobile LiDAR. It's just a little bit simpler. For 5 years, I have preached, don't use digital twins on pavement. It sucks. It's not reliable. It doesn't have the vertical accuracy that you need. And then it's wonky in places. Sometimes you can't predict it. Daniel has been working hard to prove me wrong on that, and so that's a project that we're going to present today. We've done 2 5-mile, 1518, is that right? 1518 interstate construction, reconstruction, pavement, full depth pavement projects, and we're going to show some of that today. We have been successful in using digital twins to get to that pavement level. We are getting to percentages of an inch. We're getting to 2, 3, 5 millimeter in vertical accuracy reproduced. So if you take your RTK drone out there or your RTK system and you shoot against our points, you're going to get zeros because you're in 2 to 3 centimeter accuracy all the time in RTK. 2 to 3 centimeter accuracy for pavement design isn't great. We can do better than that with digital twins, and I never thought that was possible. So I think the algorithms are changing, the AI is helping, and better cameras. But that's just kind of an update where we are on some of those, and I'll get out of the way and let the rest of these guys talk about some of those. I always make fun of other DOTs. I'm a critic about this. I hate it when we do our toys. It's like showing you pictures of my kids, you know, well, look how good this one is. But that's just something everybody does when we do this. But Jesse's going to take over.
Hello, everyone. My name is Jesse Bennett. I head up our surveying and mapping, also oversee our UAS program. So like the gentleman said from Texas, you know where he's from his accent, you can probably tell where I'm from. But you've heard a lot the last few days on return on investment, ROI. So we're going to show you, Daniel's going to show you a few projects that we've had good, really good return on investment. And even we provide, with our survey projects, we provide 100% of the time. We also include UAS data. And even if we're just extracting elements that's not part of your terrain, such as structures, buildings, guardrail, fences, you get a return on investment just from those things alone. Relatively speaking, a cheap drone. But Daniel's going to talk a little bit about some of these projects and about the cost savings. And most of our pilots are surveyors first, so they know how to set a really accurate control network. They know how to set good JCPs, and they know how to get good. They understand absolute accuracy. They understand relative accuracy. So we don't have a lot of time, so I'll go ahead and turn it over to Daniel, our UAS manager.
Okay, so this is, can you play the video, please? Okay, so it was just a video basically showing how we do a volumetric analysis for our Class 11 stockpile. So we have to go out yearly and capture all 177 sites. We were typically doing that conventionally. We moved to doing it with a drone 5 years ago. This was our ROI, so it was a huge deal. So in 5 years, we're over $1.5 million in cost savings with an initial investment of less than $10,000. So this was the ROI calculation that we did for this interstate mapping project. It's all there in the numbers. We saved $76,000 compared to what mobile LiDAR would have been. It was a huge deal. Travis had always told me that we would never be able to get pavement from a digital twin. I thought that wasn't the case, so I flew our M300 with a P1 sensor at a little under 200 feet. Giving us a ground sample distance of about 0.3 of an inch. It worked out very, very, very well. So this is just going to be showing off basically how we did this processing. So we didn't actually try to create a terrain from the digital twin. We actually went and created CAD line work and manually created all the features. So we're not trusting a surface that was created by a software. We treated it like you had a surveyor sitting in front of a computer getting all the shots. Worked out very, very well. Some of the things that we kind of learned with this was you really, really have to be careful where your guy is clicking the mouse. On a project that's this size, it is just so big. So going back through and quality checking things is very tough. You can see here the guardrail lines, they're kind of missing in places. He clicked inaccurately. It kind of sucked. We'd already turned it in. Not a huge deal. That's not usually a 3D design element. It just is where it is. I didn't really know that this was possible. Whenever I approached Travis about it, I kind of distrusted our people and the equipment. We've been doing this for a while. It worked very, very well. Waiting for the video to progress here. Sorry, it's taking longer than I thought it would. Okay, so this is showing a section of this. We broke it into 1 mile sections. It was just going to be too much data to process all in one swipe. Each mile was about 2,000 photos. We process everything locally on our own machines. We can't get anybody up the street to go along with allowing us to use a cloud processing service. So we have to process everything on our own machines in-house, and it leaves a lot to be desired. Paul, do you want to start the video? I can't. Well, I don't know why my videos aren't working. But, so I was actually going to show, we actually got some pipe inverts with the reality data. It was very, very impressive. It wasn't something that we were trying to capture. We just kind of lucked into it. Very, very impressive. The video was also supposed to show the overall level of accuracy. We were able to even model the rumble strips. I don't know how much value that really adds, but it just goes to show the level of detail that we were able to get. So, and this has been a big deal for us. So once we capture a big reality data set like this interstate mapping project, what do we do to be able to share it? These file sizes are massive. So getting a designer to download this file from ProjectWise and then attach it was kind of a big ask. So being able to share things through context share made things a massive improvement for us. Okay, so this is another section of that, loaded in Bentley's iTwin experience. This is web-based software. So I was honestly shocked at how well this worked. When Bentley first came to us with their cloud-based software, I was very skeptical. How can a browser handle this file size? And as you can see, it does it pretty well. The way that they load their level of detail works very nicely. We're still looking for a great use case for putting them on the cloud. I don't know who is going to use this for now, but it's very neat. So I'm going to show here a measurement. The measurements are actually very nice too. You can get all the measurement data from this, and you'll actually see that on the right side here. Not only do we have the distance, but we have the slope, we have the start and end point coordinates. It's very nice. It works very, very well. The one thing that I wish Bentley would give us would be some more CAD tools inside of this so that we could get more people to use it. I think that there is a great use case for this though. And the same process for uploading this here is the same process for uploading it to context share where it can be used and attached to models. So it makes it a pretty simple process. And then this is one of the first bridge inspections that we did. We flew this with Phantom 4 RTK and Scadio 2. And then the blue lines are the AI crack detection that was performed by the iTwin experience on the cloud. So We didn't run this on a local machine. It did this for us, and then it's pretty slick that you can actually output a CSV of all of these cracks. Place that we're looking to improve would be, and it's not really us, it's just a hardware limitation, is some crack depth. Once we get crack depth, I think we could get our bridge team really on board with using this. This project only took us a day to capture, but the issues were trying to capture it was very difficult. Or not trying to capture, trying to process it was very difficult. So we had issue after issue with trying to process this stuff, and part of it was a data capture issue. This was the first time we ever did it. It did work very, very well, though. And this is on survey grade control. We used this model to create CAD work. We modeled the bridge piers from it. With conventional methods, basically, the only way that we're going to get the top of this pier, that you'll see in a second, is with a terrestrial scanner. It's typically how we would have done it. But even with a terrestrial scanner, how do you get set up to where you can see the top of this pier? It's kind of impossible. So this gave us a way that we were able to do it. They were actually outperforming an inspection, so you'll see they've outlined some of the delamination areas. Worked very, very, very well. You can actually see there's places that don't look as well as others, and that is because the ground sample distance in those areas wasn't as great. Part of that would be Scadio. We were just learning how to use it, and there were some setting issues here. So you can see, like on the crack, it definitely got a bunch more photos. We got a bunch more data. But then to the left side of the screen, it looks kind of blurry. We just didn't capture it very well. We learned a lot of lessons on this one. So this is our typical workflow. So we're going to go out and send a survey crew out. They're going to set their control like they typically would. They're going to survey all of the underground utilities, anything with very thick vegetation. Like Travis said a minute ago, pretty much we're focusing on using photogrammetry. So they'll set the ground control, the pilot will come out and fly it, we process it, and then we take the model to the already created CAD drawing that we created with the survey data, and then we just, like I mentioned a minute ago, we just add the features from the model. So we're not trusting software to give us a surface. We just create the surface on our own by adding elements to the drawing. So this was a project that we did kind of early on with the drone. All of the structures here were created from the drone flight. So we had, I think it was 115, yeah, 115 structures. If we had to do this conventionally, we would have been here for a long time. Every house had a fence. People, I mean, it wasn't the nicest neighborhood. It would have been tough to go in the backyard of every one of these houses. We would have been there for a very, very, very long time. It made this project go from 5 to 6 weeks to we had it done in 1 week, a deliverable ready to go. And then I know we've talked about railroad before. So this was another one. It was a massive railroad overpass inside of our project, and they needed rail data. Getting up here would have been a pain. It's very expensive, very hard to coordinate with them. It worked out very, very well. This was one of our first times that we extracted top of rail from the model. It's a massive cost savings for sure. Any questions? So one of the videos that didn't load actually showed that. So anytime that we attach the drawing, the first thing that I look at is how the ground control hits in relation to the surface. So the point will show up in ORD. This is where the ground control was, and then I can see in the model where the surface was. So the first thing I do is I'll measure the distance between the center of the ground control point and the model. In the example that I showed, it was actually about 1,000th of difference from the ground control to the model. And then we actually go out and shoot cross sections in key locations, and we'll compare those two. Thank you.
So I think we got lucky with the sun on some of these because you'll see it. I think Paul's going to try to get the video up. But having DIs, the typical in the middle of the median with the grate, it modeled to the bottom for the drainage and each one that we had. So we must have had enough light in there. It's like we've discovered, and a lot of you that do digital twins probably figured this out. If you get in really clear water, you can model the substrate in water up to about 2 feet. That's where the refraction starts messing with your photos. Up until that point, we went back out and ground truth that. It's within RTK, so it's within 2 centimeters. We have an environmental project that we have an endangered species that's a crayfish. That's pretty common in our state. That we have to count the sizes of different boulders or rocks that are in it for the substrate. And we were able to do that, just catch the water clear. And so there are some things like this that are still kind of, we're looking at. I'm still a little shocked at the level of accuracy that we're getting with this pavement. But like Daniel said, it did work out really well. We've had problems if you've done it in new pavement, you know, where it has that sort of homogeneous look to the whole thing. So it's like doing these concrete structures with the Skydio that's 3 foot from it. When you have photos that are 3 foot away, this side of this pier looks exactly as 600 of the other pictures that are there, so it has a hard time stitching all those together. But what we're finding is that when you increase pixels, so if you up your pixel rate, then some of that wonkiness that goes away with the homogeneous areas. And so we've been testing that in different areas, and this is one of our first projects to actually say with confidence it's doing what we need. So if this gets better, so let's say we're right in this and this gets better. So if I typically would do a mobile LiDAR project for a pavement reconstruction. If this is doing what it's doing, the price comparison is not comparable. The level of effort on our end, on your end, on our consultants' end, completely changes as these digital twins. And as we've seen in the last just 3 years, it's made a big jump. If you jump back 10 years when we first looked into digital twins in like 2012, they were GIS at best. 3 foot vertical accuracies, horizontal, they make really good mosaics. Okay, great, but that's not survey grade. Now look where we are today. If I fast forward 5 years from now, it's going to scare people. This might even do away with some instances where we don't need mobile LiDAR. We'll be able to do this. And that'll really change our industry.
Can I get the video to go on slide 123? Okay. Yeah, so that was, to answer your question, that was where I was actually showing the QA/QC checks. So there was about a tenth of difference on some of our shots. But, I mean, if you send 2 surveyors out to shoot something conventionally, like a bridge deck, you're probably going to get about a tenth of difference anyway. The absolute accuracy was definitely there.
The other thing you want to add in is redundancy is not always calculated in surveying when it comes to accuracy. But the redundancy that we find when you have that many shots, you would never collect that many shots typically. And so the other thing good about this one is that it has a lot of that differential in the pixels because the road is terrible. So that really helps. You got all those cracks and all those patches. But when it's modeling thicknesses of something that's been painted about 17 times, I know that's millimeters, but we are modeling the paint stripes. We're getting to that level with digital twins. And, you know, some of these, to plug one of these out here, this phase 1, something that has 100 megapixels, you're going to see that kind of accuracy. And then controlling it with good ground control. See it.
Yeah, so typically whenever we started this, the reason that we never thought it would work, we were flying too high. That was our biggest issue, and then we didn't have a sensor that was high enough quality. So we got a lot of rough spots, and now you can see it's as smooth as it really is in the real world.
And most of you probably know this too, but flying at different HI, so fly different heights, flying overall with a heavy camera at say 250 and then dropping to 150 makes a big difference, especially in context capture. It brings them all together a little better. So yeah, 2 different heights, 2 different flight sets. Sampling rates are important. You know, that's 70, 80%. Go ahead.
Zenmoose P1 with a 35 millimeter lens. It's a DJI product.
Zenmoose P1, it's a DJI, yeah. So about 17,000. And then to jump up to the 100 megapixel, you're talking about 55,000. So
I think it's a 42 megapixel camera.
yeah, so this is 42. The X10 I think is 60 something. So we're interested in testing it as well.
And as most of you know, the higher you fly, the easier it is for the software to stitch stuff together. The lower you fly, the better your ground sampling distance is, the more accurate it is. And so a lot of that affects it, the type of camera you got, your control. So as surveyors, we're managers of error. We want to eliminate as much error as possible. So you can do that through the equipment, just best practices.
The other thing that was huge for this was we upgraded our GPS equipment. So this was all this control was set with the GPS. By the time that I would have set control with a total station for 8 miles, we would have built in so much air, it would have been very bad. So we were able to use another plug for another company here, Trimble, their new R12s. That's what we used to set this control with, and it definitely made a huge difference.
Any other questions?
Yeah. To the crack detection, honestly, I'm not an inspector. Just developing the AI a little more, the machine learning needs to keep going, and then export it into a format that's usable. So as much as we hate to do it, everything gets turned back to 2D. That's what is going to need to happen with the crack detection to make it able to be put into an inspection report.
There are some softwares that will quantify, repeat, and then classify cracks too. So I know TopoDot, that's more in the point cloud side, but TopoDot does that. They'll tell you whether it's alligator, transverse, or longitudinal, and then it will plot them all for you. So there's some of those kind of tools. I would think too, like I just had a company a couple weeks ago call me. They had a clean and paint. You don't think about drones for a clean and paint project, but we have got a lot of clean and paint projects. We have 7,000 bridges in West Virginia. So that's a lot of clean and paint. Just calculating surface area on piers, trying to pull old data, old plan sets to do that. Instead, they did, it was a big section of I-70. They used a drone just to get a rudimentary model of all the piers and then just pull the surface area off all those piers so they could calculate the paint more accurately than what they would have been. And so you don't think about that in some of those applications, but it did work really well. We're in a Pathfinder with Bentley, so some of the stuff is still NDA, but they're coming up with some of these tools to add them into AssetWise. So if you're a Bentley shop and you use AssetWise for your bridge inspections, I will tell you one thing, start modeling all your bridges and put them into AssetWise, because then it introduces what would essentially be GIS for bridge inspection. I talk about this all the time. Like, if you ever read a bridge inspection report, I know a lot of you here do, a lot of you write them. It's like, you know, they're trying to describe something with words that really should be visual. And so once you add that 3D model, if all you do is push pin your issues to that bridge, then you have went exponential. If you never use it for inspection, if all you do is add all the issues with push pins, now you're back to like what GIS days were 20 years ago.
Say that again, please.
We didn't close it.
We didn't close the road, so that was another a factor with the data capture. I made a strong effort to not fly over the roadway. It took a lot more flight plans, but it's easy with the M300. You just press a button and it goes to the next one. So every curve we split up into like 2 or 3 flight plans every curve, just to keep it one side of the road, median, the other side of the road.
The cars aren't there because they didn't sit still long enough to be into the model. So it takes all the cars out.
Yeah, that's why it looks like there's no cars. So with photogrammetry, if it's not in 3 pictures in the same place, it doesn't put it in the model.
No one ever complained for being early for lunch, so it's 11:45 if Alicia's done with it.
Thank you all.